Hello, it's Keith here, and this is lesson 2 of the platform-specific series of my TI-99 assembly programming tutorials. In each lesson, we're looking at a different part of the hardware, and we're discussing how to make it work, going direct to the hardware where we can. Today, we're going to be looking at the keyboard and the joystick, and I say that because they're basically both the same thing. The joystick is mapped as an extra sort of column of the keyboard, so to speak. Now, if I just fire up my example code here, just bring it on screen here. Okay, and then if I get my joypad here, I've got it here, and if I press up, down, left and right, you can see they're affecting this line here, and if I press fire you can see it there. So that's the joystick, but then if I go to the keyboard, if I press Q, W, E, R, T, Y, you can see all the other keys are other places within the joystick map here. Now we're going to discuss the actual layout of the joystick and the keyboard, and we're also going to discuss something called the CRU. Now the CRU isn't something I ever needed to use during my main tutorials. It was only when I came to using the keyboard that I needed it, which was a bit of a surprise really. Now the CRU is basically, it's a bit like the outs on the Z80, that's what I think of it as. It's a way of addressing bits of hardware that are connected to the processor that aren't memory mapped. So you can't access them through the sort of standard memory addressing. You have to use this thing known as the CRU, and very much like the Z80 where you have to use BC as a register to transfer a address to select, with the CRU we have to use register 12, and that will select a CRU address, and then we can transfer data in and out of that CRU address. We can select a column and we can read data back from those lines of the keyboard. Now the keyboard uses a sequence of addresses. It uses address 24 to select one of the columns, and you can see each column has a set of keys, and column 6 has joystick 1 and column 7 has joystick 2. Once we've selected a column with CRU address 24, we then use CRU address 6 and onwards to read in the actual bits of that column. And the way it actually works is we can select CRU address 6 and then we can test the consecutive bits with the commands, and that will actually use the consecutive CRU addresses automatically, so we don't need to worry so much. Now the example we're looking at today, if you look at it here, is loading in a separate column into each visible line of this output here. So if you look at this top line here, if I press the equals key, for example, you can see that the first bit here is being shown at the right here. Then if I press space, you can see that's the second bit here, and if I press enter, you can guess that's going to be the third, and so on. Now enter is the third bit here, but if I press this OK here, you can see that that's the column down. So column 1 is the second line here. So if I press enter, it's this top line, O is the second line, and if I press I, because that's neighboring here, that's the third line, and so on. So we're outputting the entire key map as a bitmap here, and this is allowing us to test individual keys. Now at the bottom here you'll see there's a minus. This is a separate test. If I just press my up button on the joystick, you can see this changes to an exclamation mark, and we'll discuss how that works in just a moment. Okay, so let's go over to our code now. We've seen this key map here, and let's learn how we can use it. Right, okay, so there's two parts to our example. The first part, we're going to dump entire rows of the key map, and of course including the joystick of course, into a register, and then we're going to show that to the screen with this monitor flags R4 function here, which we're not going to discuss. That's just a copy of a previous thing. And then we're going to test an individual bit of the key map. We're going to test the joystick bit 4, and that is the up button, and then we're going to either show an exclamation mark or a minus depending on if it's up or down. So we've got this code here to do that. Okay, so how do we actually work with the CRU for using the keyboard? Well, as I say, we have to use register 12 to transfer an address value from our processor into the CRU to select data. So first of all, we want to select CRU address 24. This selects the column. We want to select column 0. So we're loading 0 into register 2 here, and we're selecting address 24, and we're loading that into R12, but that hasn't done anything with the CRU yet. We need to transfer the column number from R2 into that CRU 24 address here, and the way we do that is with the LDCR command. We specify the register we want to transfer data from and the number of bits that we want to transfer from register 2, and so this is effectively the column. Now of course the column goes from 0 to 7, so that's a total of 3 bits of value, and that's why we're transferring just 3 bits here. This has now selected the column that we want to choose from. Now we're going to start from column 0 here, but we're going to increment R2 each time. Effectively, we're going to be transferring consecutive columns each time here. Okay. Now we've now selected the column we want to read from. Next we need to select the CRU address that we're going to read data from. So this time we want address 6. We're loading that into R12, and then we are going to transfer a total of 8 bits from the CRU into register 4 with the stcr command. Now CRU address 6 is this one here, and when we transfer the 8 bits, we're effectively transferring 8 consecutive bits from these addresses here, and this is effectively transferring an entire column into register 4 here, and that's why we can then show register 4 to the screen to see the status of each of the bits in that register. And next we're going to increment R2, which was the column number, and we're going to add 1 to that, and we're going to repeat until we've done all 8 columns of the keyboard. So effectively next time we'll be loading the value 1 in as the column we want to select, and then we'll be repeating accordingly. Each time we've got to transfer that to CRU address 24 here with this transfer here. Okay, so that's the first thing we're doing, and that's reading in the entire keyboard. What about if we want to read in a single key? Well, this time we're going to read in column 6. Why column 6? Well, column 6 is the joystick here, and we're going to look at just the up key here. So we're selecting column 6 here in R2. Again, as before, we're selecting CRU address 24 because that's the column select, and we're transferring the 3 bits, that's the 3 bits that make up this 6 here, into the CR via register 2 here. Then we're just selecting address 6 as the CRU address via R12 again, and this time we're using TB, which is test bit, and we're testing bit 4. Well, why bit 4? Well, because bit 4 is the up key for joystick 1 in column 6. You can see bit 4 here, column 6 here, and that's been tested here, and we're either going to show an exclamation mark or a minus here. So if I just run this, here's our second example just at the bottom here, just down here, and if I press the up key you can see it changes to an exclamation mark here. So that's just testing a single direction. You can see all of the others do nothing, and that's because we're testing bit 4 of column 6 here. If I change this to test bit 0 and I run again, where you can see it's even got a clue on screen here. If I just continue here, well, now if I press the fire button, that's changing to an exclamation mark, and you can use this to effectively test every direction of the keyboard, and that's what we're doing here. We've got this example version here. We're selecting column 6, the joystick here, and we're going to test each of the directions here, and we're going to move a player icon accordingly. So if I just fire this example up here and we just move around, you can see we've got a little smiley character. We can move around the screen using the joystick. I'm using my joypad here, and so that's how we can actually turn this into workable code from that reading in from the CRU there. And that's about all there is to it. Now the CRU I found very confusing because it's a little bit abstract, and it's weird that you never need to come across it with working with graphics and things and even sound. It's only really keyboard and joystick input that I've had to use it on the TMS 9900, which is very surprising really, but that seems to be the way it is, at least for the TI-99. Anyway, there we go. That's all we're going to be covering today. Of course, you can download the examples from my website and hopefully compile them and things like that. So please go ahead and do that if they help you out. If you've enjoyed this video, please like and subscribe. Liking the videos encourages YouTube to show them to more people, and subscribing just generally encourages me to keep making them. But whatever you do, I hope you enjoy the TI-99 and your programming projects. Thanks for watching today, and goodbye.